Hello. Origami provides rich opportunities for students to play with the shapes and develop mathematical insights into geometry and algebra and perhaps a lot more. Let's do an origami project. And here I have a 6-inch square, as you can see. We're going to fold the square, a 6-inch square, into a equilateral triangle like that, and perhaps one more step and make a 6-point star like that. All right, let's get started. I'm going to go very slowly so you can follow along. I'm going to try to add a lot of mathematical terms. Do feel free to fast forward if you're watching this, depending on your background. All right, so I have the 6-inch square here. Let's first fold the square. Okay, it's blue on one side and it's white on the other side. Let's first fold the square in half horizontally. Okay, try your best to be accurate. We now have two overlapping rectangles. You can fold it again vertically, creating 4 overlapping squares like that. Or you can open it and fold it vertically in half. Okay, so up to you. And I'm going to rotate it and fold it again horizontally in half. For the purpose of discussion, I'm going to open it and draw these two intersecting perpendicular lines. That's the vertical line of reflection, right? And that's the horizontal one. All right. Here we go. Now we have the center for the square. You can slow down and have a discussion about the area, the perimeter of these squares, if you like. Each of the little squares is 1/4 of the original, right? The original measures 6 inches by 6 inches. So each of these little ones, little squares, has an area of 9 square inches, if you like. Otherwise, move on. So we have a square here, and this next step is really interesting. Essentially, we are folding the right edge, okay, the right side, to the other side, okay, like this, so that the upper right corner goes to a certain point on the horizontal line, okay, like that. And that point is also 6 inches away from the lower right corner here. So we are not going to have a situation like this. We're going to push that point further to the left until that point is 6 inches away from, or one side length away from that lower right corner. Okay. Try your best to be accurate. And when you're happy, run your fingers along the crease and press really hard. Essentially, this point here is the rotation of that right side, okay, like this, as if you are using the lower right corner as the center, and then you are rotating this edge to this point. Okay, it's really interesting. If you have a pair of compasses, you can always find that this point here. Let me mark this point. Okay, take a pair of compasses and open it to the side length of this square, like this, and then rotate it. or they don't always use compasses in doing origami, but certainly you can. Anyway, this point is really interesting. As you can see here, from this point to this lower right corner, we have 6 inches, the side length, okay, if you are using a different square. But from this point down to the lower edge, we have a right triangle. Do you see a right triangle there? So that point to the lower edge, okay, you can certainly draw a right triangle there. That is 1/2 of this edge. This edge here is the hypotenuse of the white right triangle there. So that's 1/2 of the hypotenuse. So this is a very special right triangle. You can prove it that this angle here is 30 degrees. Okay, let's not do it right now, but that problem is very interesting. So this manipulation creates a right triangle that's worthwhile to talk about. Now, if that's 30 degrees, and the angle here is also 30 degrees, because under it there's another angle. So essentially, this line, okay, this line is one of the angle trisectors. So we have 30, 30, and another 30 under it. Anyway, that's a long explanation, but nonetheless, it's very interesting. Next, we are going to fold the left edge, okay, to a point here, to the point where the vertical line intersects with this new line here. Okay, let me mark it like that. Okay, we're going to fold the left edge, okay, to this point, like that, and move it up and down until this line also goes through the vertex at the lower left corner. All right. Again, try your best to be accurate. All right, that's what we have. Of course, you could have opened the square and done the same thing. So fold the left edge or the upper left corner to a point here on the horizontal line. So that point is also one side length away from the lower left corner. It's the same thing, as you can see. All right, either way is fine. Let's review for this right edge that way. So we have a shape like this, and then going to fold the left edge so that it touches this point right there, okay, where the vertical line intersects with this new line. Okay, imagine a line there, like this. Using the same argument, we can show that this angle here is also 30 degrees. It's the same thing. It's symmetrical. Now, we have a little bit of extra there. Okay, can you see? And we are going to fold it onto the triangle. And if you like, you can tuck it in. Like open it, okay, fold it first, and then tuck it in. Now we have a equilateral triangle. All the 3 sides are congruent, and all the 3 angles are 60 degrees. You can stop here if you like. One more like this. Or you can move on and spend more time to play with the the shape. All right, let's flip it and fold each of the three vertices, three corners of the triangle to the opposite side, the midpoint. Okay, the midpoint of the opposite side. Okay, fold it like this. All right, you can open it or you can just keep them overlapping like that. Okay, second one. Now we have our third one. Fold it. All right, now we have a small equilateral triangle. You can stop here or continue. So there are many ways to play with an origami project, and feel free to stop anywhere when you're tired, okay, or when you are so happy, or keep moving to the next step. And there are always other ways to do the same project. All right, now let's open this triangle. You can see there we have the center point there, the center point, the center of the triangle. And for the next step, we want to create a 6-pointed star. Okay, we're going to take one corner, fold it to the center point of the other side, and then we're going to fold it back along that line that goes through the center of the triangle. Okay, estimate, fold it back. All right, so we have one point there, and we're going to do the same thing to the other two verses. Fold it, and then fold it back along the line that goes through the center of that triangle. You can estimate. Practice makes perfect, and that certainly applies to origami. Our goal is not to make a perfect star, but rather to play with the ideas. Okay, we have the last one, fold it, and fold it back. All right, so now we have a small equilateral triangle there, and on the other side we have another equilateral triangle. You can tuck them into each other if you want to, like this. So they're going to support each other. Does that make sense? Okay, so tuck them into each other. Right, tuck these corners in. You don't have to do that. If you really want these two triangles to stay together, you can use some tape or staple them together. So it's as if we have two overlapping triangles, small equilateral triangles, and one is rotated. How many degrees? 60 degrees, right? Take one and rotate it, and we have a shape like this. A 6-pointed star. Does that make sense? All right, we started with a square, and we fold the square into an equilateral triangle, and from there we made a smaller equilateral triangle and further made a 6-pointed star. And depending on your goal, you can slow down or stop anytime and have a mathematical conversation. Talk about the measurement of the shapes, okay, and the measure of the angles, and how these shapes are symmetrical with each other. Again, do remember there are other ways to do the same project. You do not have to follow these steps exactly. Try to be creative and develop your own perspective on origami projects. Of course, you can use compasses if you like. I would like to have some students play with the compasses as they fold that this edge. Okay, pull this right edge onto the other side, and this step can be difficult, but when you take the compass and measure the side length and then rotate it and find that point, and it can be easier for some students. All right, and then you fold this point directly to that point, so we know the distance between these 2 points. That point and the lower right corner is the side length. Why? Because if you had used the compass and you made sure and they are the same. Anyway, be creative and be flexible and see how you can integrate some of the origami projects into mathematics, and both in the classroom and also outside the classroom, after school programs, for example. Thank you for watching.